Hey, Algebra 1, wanted to jump on and do Monday's session of Delta Math, trying to kind of push us to review some of the skills that I know will be on your Edulastic assessment. That will be near the end of our session, kind of close to May 18th. I'll have everybody sign into Edulastic at a designated time, and you will do work on a sheet of paper that you will later turn in or take pictures of and submit to me so I can kind of look at your work. And so let's go ahead and jump into Delta Math. So follow the link that I set in your Canvas announcement, and hopefully from the other video you've already watched, it kind of shows you how to set up that Delta Math assignment. And so this is kind of day 2, jumping in and working on some more problems. So last time we worked on linear functions, and we're going to keep that going, and we're going to practice some more of these ideas, kind of review them. So this next one says, write the equation of the line fully simplified to slope-intercept form. So when they talk about slope-intercept form, that's the whole idea of slope being m and the y-intercept being b, so y equals mx plus b. They want me to write an equation that follows this style. And so the m is a letter, it looks like, but it really represents how much it rises and runs, and that was what we did in the last video. One of the other skills was trying to get you to calculate slope of a line by finding 2 points and calculating their rise over run. So it looks like it's going up 1 over 1, and so that m just needs to be a 1, or in this case you could just put x, like 1x there. And then the b, that represents where it hits this y-intercept, and that seems to be the value of 5 right here. Now, a bigger thing that's going on is we're calculating an idea of when x is this number input, the math gives you out another value. So for example, when you plug in 2, that point corresponds with an output of 7. And if you think about it, if x was the number 2, 2 plus 5 would be 7. Or if you picked another point like 6, well, 6 plus 5 would be 11. So this is more or less what you're calculating. You are creating an equation where all of those points that you see, whenever you plug in the x value down here into your equation, you get out that corresponding point that represents the output, or where it would be on the y-axis. So let's try another one. That one gave us a positive slope, and this next one looks like it also gives you a positive slope. And so you do have to, I kind of missed it whenever I changed the video here, you got to go to the next problem, which is in the top left if you're still on that first problem there. So same thing, it's wanting me to write this y equals mx plus b, most simplified, and it looks like it's going up 1 and over 2, up 1 and over 2. So basically, it's only going up a half each time you go over 1. So from 0 to 1, it increased like a half right there. And then it goes up another half. So basically, it increases a full 1 every time you go over 2. And so that's where you're getting half of the x input every time. And so now that y-intercept looks like it's 4. So I want to do a plus 4 there. And then, of course, I'll test it. Half of 6, I'm just going to pick a random point here. Half of 6 would be 3. And 3 plus 4 does, in fact, make 7, which would be the output when you plug in 6 in your equation. So do enough to go ahead and get, you know, those all filled up, 5 out of 5 and all that stuff. I'm going to go back and let's look at some other types of problems. Okay, standard form. So standard form is a little different because the output variable y and the input variable x, they're on the same side. So they're wanting me to change this and put the equation of the line into slope-intercept form, that other equation that we had. So I'm going to pause the video and put this in my other software. 1 second. So you'll definitely need a piece of paper to do this activity, to do it well, to really improve your skill on it. And so hopefully you take out a scratch sheet paper when you're doing this section and kind of follow along the steps that I'm going to try to show you now. So we really want y equals mx plus b format, and really what that means is we need to solve for y. We need to get y completely by itself. This y right here currently has 4 in front of it. It's got minus 4x. We need to move all of that to the other side of the equation. So the first thing that I want to do is I want to kind of deal with this fact that you're subtracting 4x. It's easier just to go ahead and add that 4x to the other side. And if you're really good at this, you would know that these do not go together because they're not like terms. They have to both have the x, or they have to both not have x for them to go together. So that means I have 4y equals 4x plus 16. And I'm going to put the 4x in the front of this because, again, I'm trying to follow this mx plus b format where the x is in the front. So the next thing I want to do is this 4, anytime they're up against each other, like a number and a coefficient, or sorry, a number and a variable, 4 is the coefficient, but they're multiplying because they're up against each other. So I want to divide the 4 to the other side. And when I divide everything by 4, this will reveal what my final answer is. So 4 divided by 4, that would just leave 1x, and 16 divided by 4 is 4. And so now I have changed this into slope-intercept form, and basically it needs to be y equals x plus 4. No negative, that was a typo. And so let's see how we did. And it says we're doing well. So let's go to the next problem. And then it says put the following equation in slope-intercept form. Let's do another one. Let me pause the video. So I've taken time to write that down in my software or on my piece of paper at home. And same idea, I'm trying to get the y variable by itself. Now in the other problem, the order was kind of backwards. It started with the y and then had x. And this is more common, the standard form order here, where the x is in the front, then it's y, and then you have your constant. And so the steps are really the same. I'm trying to move my x term to the other side, and for this one it was positive, so I do want to subtract to get that to move away. So 15y will equal negative 3x minus 135. Let me move that over here. So again, I don't want to put these together because they're not like terms. If they both had the x or if they both did not have the x, that would be a completely different scenario. So I just want to move that x to the other side, and now these are multiplying. 15 and y are multiplying, so I want to divide these by 15. And now I want to simplify this as best as possible. And so even in the directions, I'm sure it says something about simplifying if needed, simplifying all fractions. And so that means this negative 3 over 15, those are both factors, or sorry, multiples of 3. So 3 times 1 or 3 times 5 would be 3 and 15. And I do want that to still be a negative coefficient because it was a negative over a positive there. And then negative 135 divided by 15, let's just see what that is. 135 divided by 15. Ooh, 135 divide 15. Yeah, that couldn't have gone up. You know, when you divide by 15, it should be going down. So I knew that was wrong. So that is a negative 9 there. So this is what I'm going to type in to see if I got it correct. Y equals negative 1, I'm not typing, y equals negative 1 divided by 5, and then arrow to the right here. I don't want x in the coefficient. Here, I'll show you if you do not arrow. You're going to put the x down there, put the x out as a coefficient, and then it's minus 9. And then let's submit our answer, and it looks like we got it right. So I'm going to back up, and we're going to continue. We got a few more minutes, got a few more skills here I want to do. Compare linear features versus, the graph versus the table versus the equation we've been talking about. So it says find the x-intercept of each line defined below and compare their values. And then it says select values from line B. And then it asks the question down here, the x-intercept of line A is... Well, the x-intercept always happens when the y value would be 0. So I want to kind of take a moment. I'm going to bring this into my software. So now that I can look at it in a place that I can kind of write on things, let's look at it again, the x-intercept of line A. So the x-intercept, again, the x-intercept means that the y value is 0 in terms of like your x and y points. This y value has to be 0 if we're talking about an x-intercept. So I'm going to plug in 0 for y, and 0 plus 9 just makes 9. So now I want to kind of consider dealing with this fraction here. I think I want to multiply everything by 2/3. That is the reciprocal of this 3/2. And if I multiply by the reciprocal on both sides, what's going to happen is it's going to undo this fraction. See, these 2's will divide to be 1. And these 3's will divide to be 1. But when it moves to the other side, I have to kind of think, well, 2 times 9, that would be 18. And then you have to divide that by 3, making 6. So now I have undone that, and I have x plus 2 that equals 6. And this is a fairly easy question now, because it's like, what number plus 2 is 6? Well, 4. 4 plus 2 is 6. And if you want to follow a more algebraic procedure, do the opposite of adding, which is subtracting, and that does give you the value of 4 here. Now, I wonder if it wants me to put the point or just the value. I'm going to think it's probably just 4. So we'll just see what happens. If it rejects it, then I'll go back and put the ordered pair there. Now it's asking for the x-intercept of line B, and this one's a little easier because they give you a table. And the x-intercept, when the y is 0, it looks like it's -1 there. So now it says, therefore, the x-intercept of line A, would that be less than, greater than, or the same? So which one is, the larger value? So it looks like the one from A is 4, the one from B is -1. That value is greater than. Let's see how well we did. Check. Got it perfectly right. Okay. Let's try make a table and see what that looks like. So it says Alyssa filled up her car with gas before embarking on a road trip, and the car uses 2 gallons of gas for every hour that they drive. And the capacity of the tank, which how much the tank can hold in total in terms of gasoline, is 14 gallons. So it says make a table and then write an equation, and let's represent the number of gallons remaining in her tank after T hours. And so it says a little bit of important information there. The car uses 2 every gallon, but it is a 14-gallon total tank. And so it says she filled up her car at the very beginning. So if she has not driven yet, that means there's still 14 gallons in the car. Now, it says it's 2 gallons for every hour that she drives, and so in 1 hour, she's going to have used 2 gallons, meaning there's only 12 in the tank. And that's because there's a negative slope or a negative rate of change happening in the problem. She's using 2 gallons, and so I have to just keep decreasing each of these by 2. And now it says, well, what is the function? Write g of t, write an equation for the function g of t, and it wants me to use t for the hours. So you're using -2 per hour per time, and you're starting at +14. So this is really, diving deep into that slope-intercept form, what it means to build an equation from a problem, from context. So you have to really lock in on, okay, how does it start? She starts with 14 gallons, and then really thinking through the problem, understanding that she's using that, and so that value is decreasing over time. Very cool, very cool. All right. Maybe we'll do another one of those just to wrap the video up. So it says Kennedy is signing up for a gym membership with one-time fee to join and then a monthly fee, and that one-time fee is going to be $100 and then the monthly fee is going to be $50. So the idea here is that if she started, it would cost $100 even if she decided not to use that first month, because there's a one-time fee of $100. Okay, but if she was to use it, pay that fee, and then use the membership for a month, it would be $150 because it's going to go up 50 every month after that. So then another 50 is going to be 200, another 50 is going to be 250. And so we have to kind of think through, well, how does the equation work? Well, you're adding 50 every time a month goes by, but you have to start at 100. And I know that first one doesn't make as much sense because, who would buy a membership and then not use a month? Well, you really want the equation to work for all of the other ones. So yeah, this one may kind of feel silly, like when would you plug in 0 to get 100? That's really just showing what the fee would be in the case that you decided, hey, I'm going to pay the fee, and then all of a sudden you decide you're not going to use the membership and you don't get your money back for that fee. So we really want the equation to work, and you can plug in 1. 50 times 1 is 50 plus 100 giving me 150, or 2 times 50 is 100 plus 100 is 200. This equation is working perfectly. All right, so that wraps up this video and a few more problems in this section of linear functions. So I'm almost done. I think I may do one more video to kind of round those off, and then I may start another one. We'll probably start looking at sequences next. So thanks for watching the video, and hope you're doing well. Contact me by email or on Canvas if you have any questions about this process.